Welcome to Astro Odyssey. Explore the universe. There is an image that quietly unsettles people. Not because it is bright, not because it is beautiful, but because of what it represents. This is the nearest star system beyond our sun, close enough to feel reachable, yet so far away that no human has ever been there. You cannot see it with your naked eyes from Earth, and yet, nothing outside our solar system is closer. It is small. It is dim, strangely restless. For more than 100 years, astronomers have studied it in silence. And in recent years, that curiosity has grown because something unexpected is found nearby. Something that forces us to ask difficult questions about our future beyond Earth. If we could leave Earth right now and travel straight outward into space, it would take more than 4 years to reach the nearest. Stars at the speed of light. And it is not just one star. It is a small family of 3. 2 of them are similar to our sun, bright, stable, locked together by gravity. They slowly orbit each other in a long, quiet dance that takes decades to complete. From parts of the southern hemisphere, they appear in the night sky as a single bright point of light, one of the brightest stars humans can see. But there is a third member of this system, smaller, cooler, much dimmer, and slightly closer to us than the other 2. At first glance, it seems easy to overlook, but this faint star is the one that would quietly change everything. For a long time, no one realized this faint star was even there. It did not shine brightly, did not stand out. It quietly blended into the background of space then, while comparing images of the night sky taken years apart, astronomers noticed something strange. A tiny point of light had moved. Not much, just enough to matter. What made it unusual was that it moved in the same direction as the brighter stars nearby. That raised a question. Was this faint star connected to them? Further measurements revealed the truth. This small, dim star was not only part of the same system. It was closer to us than any other star beyond the sun, in a strange twist. It became known as both the closest star to Earth and the faintest. One ever discovered at the time, hidden in plain sight, waiting to be noticed. At first glance, this star appears calm. Small stars often do. But this one is not as peaceful as it seems, beneath its surface. Powerful magnetic forces are constantly at work. From time to time, that energy is suddenly released. The star erupts. In violent flares and moments, its brightness can increase dramatically, despite being much smaller than our sun. It can release similar levels of high-energy radiation, sometimes even more. These flares send bursts of energy out into surrounding space, and they happen often, in fact. Most of the star's surface is active at any given moment. Compared to our sun, this level of activity is extreme, yet among stars of its kind, this one is considered relatively quiet, a reminder of just how intense red dwarf stars can be. Unlike our sun, which will one day run out of fuel, this small star burns very slowly. So slowly that it could remain stable for trillions of years long after Earth is gone. Long after the sun fades, this star will still be shining. It wastes almost nothing. Nearly all of its fuel will be used before it ever begins to die. That means its lifetime is longer than almost anything we know. By the time it finally changes, our planet, our sun, and even our entire solar system will no longer exist. This star is not powerful. It is patient, and patience in the universe can last forever. Although this faint star sits far away from its brighter neighbors, it is not alone. Gravity still holds it in place, even across enormous distances, remains loosely bound to the other stars in the system. Its path around them is slow and distant. 1. Full orbit takes hundreds of thousands of years. How it ended up in this arrangement is still uncertain. It may have formed alongside the others, or it may have been captured long ago, pulled in by gravity during a close encounter. But this connection will not last forever. Over time, as the larger stars slowly change, their grip will weaken. And one day this small star will drift free. It will continue alone, moving silently through the galaxy, bound for now, but not forever. For many years, astronomers searched for planets around this nearby star at first. They found nothing, but they did not give up. Slowly, tiny changes in the star's motion began to appear. Small, almost invisible, yet consistent. Something unseen was pulling on the star. The result was the discovery of a planet, not much larger than Earth. A world orbiting extremely close to its star. So close that a full year there lasts only days. It sits in a region where liquid water might exist. But that does not mean it is friendly. This planet is nearby, it is familiar in size, and yet it may be nothing like home. Despite its location, this planet is a harsh place, powerful. Radiation constantly strikes its surface. Violent. Flares from the star flood it with energy. Far more than Earth ever receives. Any atmosphere the planet once had may have been slowly stripped away. Without an atmosphere, there is no protection, no stable climate, no safe surface. The planet is likely locked in place, one side forever facing the star, the other trapped in darkness. Temperatures could be extreme. Scorching on one side, frozen on the other. From a distance, it may look familiar, but up close, this world is likely uninhabitable. Years after the first discovery, astronomers began to notice more signals. Subtle hints that there could be other worlds nearby. One of them appears much smaller than Earth. It orbits extremely close to the star and is almost certainly too hot to support life. But its discovery mattered. It became one of the smallest planets ever detected using indirect methods, a sign of how precise our technology has become. Not every signal, however, is so clear. Another possible planet remains uncertain. Some data suggests it exists. Other data suggests error. For now, this world sits in between. Not confirmed. Not dismissed. A reminder that in science, every answer often leads to even more questions. Even though this star is our closest neighbor, reaching it is still far beyond our reach. With today's technology, a journey there would take thousands of years. That is longer than recorded human history. So scientists are beginning to think differently. Instead of large spacecraft, they imagine probes no bigger than a coin, lightweight, fast, designed to survive the journey. Some ideas involve using powerful beams of energy to push these tiny probes forward, sending them through space at incredible speeds. If such a mission ever happens, it would not slow down. It would fly past the star system, collecting images and data in a brief but historic encounter. For the first time, human-made objects could visit another star, not in science fiction, but in reality. This star matters not because it is beautiful, not because it is powerful, but because it is close. It reminds us that the universe is not only distant and abstract, it is right next door, waiting. This star represents a boundary, the edge of what we can imagine reaching it. Challenges us to think beyond our home world and beyond our own lifetime, whether we ever visit it or not. Its presence changes how we see our place in the cosmos. It pulls our curiosity outward, asking a simple question. How far are we willing to go? Maybe we will never visit this star. Maybe we will. Either way, it has already done something important. It has made us look outward. It reminds us that our world is small, and our time is short, yet our curiosity is endless. Long after we are gone, this star will still be there, quiet, patient, unchanged, and perhaps one day, something we create will pass by it, carrying with it the questions we asked when we first looked up and wondered what lies beyond. Thank you for watching.